This video is brought to you by Sporlan, quality, integrity, and tradition.
All right, we got a service call on an AC not working. It's a 15-ton split system. I had a hunch what was going on because they said their thermostat was blank. I don't know why this cover's missing, but that's a whole nother problem for another day. When I got up here, we had no main power coming into the unit, so I actually have a technician downstairs. I had him confirm that we had a tripped breaker, so I turned the disconnect switch off before he tried to reset the breaker. Then he reset it. Now we're gonna test to see if we actually have power up here. All right, 1 to 2, 2 to 3. Okay, cool. So we have 3-phase power now. Now what I need to do, I'm gonna leave it off, we're gonna open it up, and we're gonna try to figure out why the breaker potentially tripped. Now, a couple years back, I changed a compressor. I think it was this one. No. Yeah, it was this one, 2020. I changed a compressor on this guy. But let's check to see if we have anything shorted to ground. So again, we have power turned off. I've got my meter on tone, okay? So I've grounded it out right here, and then I'm just gonna go around with this guy, checking the compressor. Oh, we have a grounded compressor. Yep, and it's that one right there. That stinks. Let's check the other one. What the heck? Wait a minute. Both compressors grounded? I don't know about that. Let's take the wiring off and isolate them, make sure. That's insane if they're both grounded. So here's what we did. I pulled the wires off and I took pictures of them before, okay? So now we're gonna get in here on the terminals and we're testing. Let's see. So we know we still have a good path to ground, okay? So now we're just testing here. I'm testing on all 3 legs of the compressor. Nothing, nothing, okay? Now let's go over to this one. Ah, there we go. Yeah, this one's grounded. Okay, so what was happening, they only use 2-pole contactors on this guy, okay? Because they only use 2-pole contactors, one leg is always wired hot to each of the 3-phase components, which in this case are compressors. So this compressor was grounded and it was backfeeding through the common leg of power that was wired hot all the time. So that's why we were getting a grounded compressor tone on this one and this one, but then when I pulled the wires off, it was just this one. Now, that can also be dangerous because if the customer's down there resetting breakers and things like that, that's why you never want to reset breakers because you're technically shorting a wire. Now, we don't know if there's any damage to this one yet. We still got to verify, but this one for sure is grounded. So if you come right here, this is our point at which each compressor share a leg of power right here, okay? And again, I have no power in here, I've verified, but that's the leg right there. So since we have this compressor grounded, it was like it had a backwards path to the other compressor, which was giving the other compressor a false reading of a ground. Now, we still don't know if that compressor is okay because maybe the windings got damaged by the short. Maybe the customer did reset the breaker. I don't think they did, but we're gonna get in here and ohm out the windings and hope that everything's okay on this one. So that way we can at least get them one compressor going. With this guy, I wanted to test before I hooked it back up whether or not the resistance value that I was reading across the windings was correct. So I'm reading approximately 0.67 and it's pretty even across, it is even across all 3 legs, okay? So I opened up the Copeland mobile app with that model number right there, and you're able to look it up and it says that we should be running about 0.50 winding to winding, plus or minus 7%. This guy's been down for a long time. I'm pretty confident I can start it up and test everything at that. So I think we're okay, but we're going to go ahead and finish wiring it up. I gotta isolate this compressor, make sure it's completely out of the picture so that way it doesn't try to start. Let's protect the wiring so they don't short to anything. And then we'll put gauges on it and try to start this guy up. Now, these are not, this is a multi-circuit system, okay? So these are 2 individual circuits, stage 1, stage 2, all right? Actually, I think it's reversed, even though the labeling's on there. I think someone switched it down at the air handler, if I remember right. I've done work on this. I put a stand here when we changed this compressor. I made a video about it because it was a pain in the butt to get this thing on the roof. I had to use a hoist assembly and everything. So One of the things that stinks though is I know that this system is not piped correctly. It does not have any liquid line shutoff valves downstairs to prevent refrigerant migration. So this thing, I don't know how long it's been down. I think the service call came in a day ago. So who knows how long it was down before that. But theoretically, the refrigerant could be migrating somewhere else and we could have a problem with all the refrigerant coming back at once. So we have to watch that because that can wash the oil out of the compressor if it hasn't already happened. Who knows what killed this one? This one I changed 3 years ago. This one is from 2014 and these compressors do see a hard life. This customer doesn't do maintenance. It's a mess, but we're gonna go through this system and diagnose it. I'm gonna wire it back up and we'll isolate everything. I went ahead just for now and closed the ball valves for this circuit. There's a ball valve on the suction and there's a ball valve on the liquid. So I closed this one right here and then back in here underneath this, there's another ball valve. I closed that just to keep everything where it is, right? No more migration than we need to have. Next, we need to go ahead and put gauges onto this one. We're gonna check every other component, make sure there's no other shorts to ground, make sure everything else is good. Then we got to fire it up and hope that this compressor starts up and runs okay. Okay, we're getting ready to start it up. We've got gauges on the good working compressor. We have 250 PSI equalized out. When I purged it, I made sure it didn't smell burnt or anything. Doesn't. I've isolated the other compressor on both ends. It's not going to plug in. All 3 wires are safe. Contactor's tight. That's the bad compressor. We're hooked on for the good compressor. In the Copeland mobile app, I pulled it up so you can see what the RLA is. So we're looking for about 25 amps max. And it's probably gonna pull a little bit higher than that at first. We're pretty much ready to turn it on. I got the unit jumped out right here. And yeah, that's that. So I'm gonna go ahead and turn this on and back away and hope nothing blows up. And step back. Condenser fan motors are all running. That's a good sign. We're just waiting for the delay from the compressors. The condenser fan motors must be off of like a pressure control, I think. Let's just give it a bump, see what happens, make sure nothing blows up. Compressor runs. That's a good sign. Okay, well I'm gonna let it go ahead and go through its cycle and stage on, so we know it's not gonna blow up in our face at least. But yeah, all condenser fan motors are running, so that's a good sign. We'll definitely test current on those. All right, so doesn't it tell you if it's in a delay? I think it does. Maybe it doesn't, I don't know. We'll give it a second, let it start up. I just remembered I needed to have the, oh, so look, what do we got here? Flashing. Oh, I think that's the delay. I think is what that is. Yeah, it's a delay. If I remember right. I'm just doing this all off memory. I ended up jumping out Y1 and Y2 because this thing has a VFD downstairs. So before I leave, I'm gonna need to get Y1 and Y2 calling together. So that way the VFD is always running at high speed. We're gonna have a hard time depending on, I told you that I thought one of these was switched downstairs. This has a slab coil like at an angle. And if, there we go, we're running. 17 amps, 18 amps, that's not too bad. And start up. So we're gonna let it run for a bit. Pressures don't look too crazy at the moment. This is 410A-ish. Change it over. And sight glass is flashing at the moment, which is typical. It's a little foamy, that's not the greatest, but we'll let it run for a bit and hopefully it clears up and the system at least gets half the unit running so that way they can get some cooling in the kitchen because we're in the middle of a heat wave. Southern California summer, it's 105, 110 degrees outside. So, all right, we're gonna let this run for a bit and then we'll check back in a little while. Okay, we're getting a little bit closer to RLA, which was like 25, but I'm good with that, okay? Now, condenser fan motors are allowed to run 1.42 amps. So let's go ahead and test these guys. 1.67, now we also have this panel off, so we're gonna have to hold that up and make sure that's not changing anything. That one's 1.3. This motor right here is making a whining sound, this one. So I think they're losing a motor too. 1.3. So this one right here is measuring 1.6. So they're losing a motor is what they're doing here. All right, so we've got a big quote ahead of us here because that compressor's grounded. We're gonna be putting a new compressor, accumulator, reversing valve, suction dryer, liquid dryer. We're gonna be changing a condenser fan motor. This coil is dirty, so it needs to be cleaned, and it needs to be split too because this is a split coil. So this is a big boy job. The compressor that I got running, the sight glass cleared up, so that's a good sign. That doesn't mean it's the full charge, but that means that we've got a solid column of liquid at this moment going downstairs, which in the summertime, that's a pretty good sign. You do charge to subcooling on these guys because they have TXVs downstairs. So just because you have a clear sight glass doesn't mean that's going to be enough gas for all ambient conditions, whether it drops really cold outside, whether it gets really hot. That's why you charge by subcooling on these instead of just a clear sight glass, okay? So it's very important to understand that. Refrigeration with a receiver, as long as you don't have low ambient controls, you charge by a clear sight glass, assuming everything's working correctly. But on air conditioning, we don't have receivers on this particular system. It uses the condenser as a storage vessel. You got to charge by subcooling. All right, well, we don't have a condenser fan motor locally. We will have to get one, but it's okay. I've got it on will call at the local carrier, well, not local, but at another carrier distributor somewhat in my area. I'll pick it up today and we'll probably come back tomorrow. We got to get at least a condenser fan motor on this. I talked to the customer because we're already running higher than what we should be for head pressure, and I don't want to damage the other compressor. It has high pressure controls, but still, it's about, I think it was like 85 degrees in the shade, 80 degrees in the shade right now. So yeah, our saturation's a little bit high. So we're rinsing all the condensers. I'm gonna shut it down, put it back together. We're gonna rinse the condenser off. We're rinsing all the other units. Yeah, and we're gonna give them a big picture quote for this one. This one's gonna be an expensive one though, because I'm just looking, that's like 1.3", I think, for that suction line. Maybe it's 1.125". Nah, that's 1.125", but still, it's gonna be a big suction dryer. But what I can do, if I go with a encapsulated suction dryer, which I don't know if I will or not, we can also go with a core, a removable core dryer. But I can run another strut across this like I did on this, run another strut across under the suction lines to support it, and then that'll be kind of cool too. So, all right, well, I'm gonna get lots of information, lots of pictures, but we got them up and running for now. And I think they need to have us service their exhaust fans too. All right, well, that's it for now. This place is just like, it's such a pain in the butt to get up onto this roof. You got this hatch, and then it's all the way over there. All the way over there in that far, far corner over there. So some other guys working on this boxcar unit here today. Oh boy. All right, we'll get this down and other things to do. I haven't done this work yet. This was from all the way back in the summertime. Let me look at the clip right now. This clip was from July of 2023, and the customer didn't want to proceed. They didn't even want to quote at the time. I know they haven't done anything yet. A lot of customers were doing this towards the end of last year because we got it up and running. They were like, yeah, let's just see if we can make it through the rest of the summer. And then here we are coming in, you know, through the winter, and we still haven't done this work yet. And it's going to hit us like in May or June. Watch. They'll be like, we need it, and we need it now. That, like, realistically, that job, like, I can change the compressor. I can do that. But the entire system needs to be replaced, and it's beyond me. I wish I could show you the inside of the building, but I can't. But they have 15-ton split system air handlers. The air handlers themselves, I've changed one of them out in their dining room during COVID. But this one is in their kitchen above a drop ceiling, and it's probably about 6 feet above the drop ceiling. They literally built the building around this because underneath the drop ceiling, you have fire sprinklers, you have electrical, like everything needs to be taken out. The whole drop ceiling needs to be taken down to get this 750-pound air handler down, of which they would not be able to operate. Like, it's just the epic, epic disaster. And this goes to show you, people don't think
when they engineer buildings, when they design them. These never should have been split systems. The reason why they're split system is because this is the ground floor of a multi-level building and they have tenants above them. And it would have been a pain in the butt to run ductwork. It is an extremely tall building. The air ducts are just insane going down. And it's a problem either way, but they should have done something different. And you know, it's just going to be a disaster. But again, it's not my job. Like there's no way I'm doing this. Like as far as replacing the equipment, I'll change the compressors all day long. No big deal on that. But changing that equipment is going to take a ginormous multi-part crane, or a helicopter can get it done really quick. Just getting the condenser on the roof, that's no big deal. But it's got multiple leaks down in the evaporator coil. Downstairs in the air handler, just multiple leaks. It's insane. I've even done a video fixing like 30 something leaks, 20 something leaks on it before, and it's still just leaking refrigerant. It's just a disaster. Epic disaster. But yeah, they haven't done a single thing about it yet, so who knows what goes on. But I thought this was really good because, you know, the initial both compressors being grounded, that was a problem, and that wasn't the case, right? Because it was just backfeeding on that third path where they're tying the two hot legs together. Very important to remember when you're ohming out compressors, when you're testing compressors, you always remove the wiring because hidden stuff can be happening inside that electrical. So important. I really appreciate you guys making it to the end of the video. You guys got to see my process on this one. If the customer ever approves a compressor replacement, of course, I'll film it and we'll get it going, okay? Again, I really appreciate you making it to the end of the video. Leave me a comment down in the bottom. Let me know what you think. If you're interested in supporting the channel, you can, the easiest way to support this channel is watch the videos from beginning to end. That really is the easiest way. You can also support the channel via going to my website, hvacrvideos.com. We have merchandise available. You can go to trutectools.com. If you go to trutectools.com, I have an affiliate code set up with them. So you select what you want. At the end, when you're checking out, you put in my offer code Big Picture. That's one word, Big Picture. You get an 8% discount on majority of the items on their website. There's a few things the discount doesn't apply to, but when you do use that discount code, I get a small commission from it. So it's a great way to help support the channel that way, right? You get tools, I get a small commission from it. Doesn't cost you anything extra. Also, if you're interested in supporting the channel, there's PayPal, Patreon, and YouTube channel memberships. There's links in the show notes of this video for all of those. Thank you so very much. Again, I really do appreciate you, and we will catch you on the next one.